So, good afternoon, everyone. Today, we will learn about the nth term of an AP. So, basically, you should recall the example that we considered in the section 5.1, in which Reena applied for a job and she got a job for rupees 8,000 with an yearly increment of 500. So, now let us see how we can find her salary after fifth year. So, for example, in the current year, she will be getting 8,000 rupees. In the next year, her salary will increase by 500. So now the salary will be 8,500 for the second year. Now in the third year, the salary will be 8,000 plus 500 and plus 500, which will be 8,000 plus 2 into 500. We can write this term in form of 8,000 plus 3 minus 1 into 500. Now the salary after third year will be 9,000. I hope you all guys are getting what I am trying to say. I am trying to say that the salary of the third year is equal to the 2 times of the incremental year plus the previous salary. Now the salary of the fourth year will be the initial salary plus 3 times of the increment plus 3 into 500, which we can represent in the form of 8,000 plus 4 minus 1 into 500, where 4 represent the current year of the fourth year. Now in the fifth year, her salary will be 10,000 with the same ideology. Now let us try to align some pattern within these numbers. So we can clearly see 8,000, 8,500, 9,000 and 9,500. These all numbers are in an AP because the difference between 8,500 and 8,000 is 500 and 9,000 and 8,500 is also 500. So clearly we can see that these terms are forming an AP. Now let us look at something more. So let's try to like generalize this statement into a formula so that we can use that formula for further review. So the salary of the 14th year will be 8,000 plus 5,000. The salary of the salary of the 15th year will be salary of the 14th year plus 500. So salary of the 14th year will be equals to 8,000 plus 500, adding 13 times plus 500. So we can clearly see that salary of the 15th year will be equals to 8,000 plus 14 into 500, which we can represent in the form of 8,000 plus 15 minus 1 into 500, which is equals to 50,000. So in simple terms, we can say that the formula can be generalized in this term. An is equals to a plus n minus 1 into d, where a is the first term, n is the difference between two consecutive terms, and n is the term that we want to find. So we can clearly see that the first term will be a, the second term will be a plus n minus 1 into d. So for second term, the n key value will be 2. For third term, the value of n will be 3. For fourth term, the value of n will be 4. So a plus 3 minus 1 into d will provide as the third value. And a plus 4 minus 1 into d will provide us the fourth value. Now clearly we can see we have derived a relation between a, n and d to find the nth term. So the relation is a plus n minus 1 into d, where d is the difference, a is basically the first term, and n is the nth term. I hope you all guys are getting what I'm trying to say, trying to explain to you. If anyone have any doubt, you can raise your hands and we will conduct the doubt session at the end of the class. But I hope you all guys are getting what I'm trying to say, that we have managed to provide a relation between nth term, n, d and eighth term. So now let's try to solve some examples so that it will improve your understanding of the concept. So suppose we have been given an AP 2, 7, 12, ... Now we have clearly been specified that the 10th term of the AP we have to find. So the first term is 2. The difference we can clearly find that 7 minus 2 is 5 and 12 minus 2 is also 5. That means that these terms are in AP. So the difference is 5 and we have to find the 10th term. So the formula that we will use will be a plus n minus 1 into d. Now the 10th term is equals to 2 plus, over here the value of n is 10. 10 minus 1 into 5. So 2 plus 45 will be equals to 47. So the 10th term of this AP, of this series, will be 47. I hope you guys are getting what I'm trying to say and what I'm trying to explain. It is very simple. Like clearly we have been given the first term, which is 2. The difference is 5 and the term that we have to find is 10th. So the formula that we will be using is a plus n minus 1 into d, and by using the formula 2 plus 10 minus 1 into 5, we will get the value 47. Now let us go for the next example. Which term of the AP 21, 18, 15 dot 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 is minus 81? Also in any terms 0, give reason for your answer. Now we can clearly see that this is an AP which is in decreasing order. As we can clearly see, the difference between 21 and 18 is minus 3, because 18 minus 21 equals to minus 3, and 15 minus 18 is also equals to minus 3. That means the difference between the two terms is minus 3. The first term is 21. So we have to find which term is equals to minus 81. So what we will do is that we will put the value of an equals to minus 81, because it is already provided us the nth value is minus 81. The first term is 21, and we have to find, and minus 3 is the difference. So minus 81 is equals to 24 minus 3n. So from here we can clearly see that minus 105 is equals to minus 3n, and from there we can easily get the value of n equals to 35. Therefore, the 35th term of the given AP is minus 81. Next, we want to know if there is any n for which an equals to 0. Now we have to find that is there any value of n for which an equals to 0. So for that, we will use the first term equals to 21, n minus 1 into minus 3, which is equal to 0. So for n equals to 8, the value is coming out to be 0. So yeah, the 8th term of this AP will be equal to 0. I hope you guys get what I'm trying to say. We have to check whether this AP can provide us a 0th value. And when we put the value of 0 on the right hand side in the terms of an, and 21 plus n minus 1 is equated with this value, we can clearly see that the value of n is coming out to be 8. So the 8th term of this AP is equal to 0. Now let us go for the next example. Determine the AP whose third term is 5th and 7th term is 9th. So basically we have to find an AP whose third term is 5 and 7th term is 9. Now we can clearly see the third term can be represented in the form of a plus 3 minus 1 into d. That means a plus 2d is equals to 5. Similarly for a7, a plus 7 minus 1 product d is equals to a plus 6d, which will be equal to 9. Now these are two quadratic equations. We can solve these two equations. From there we can get the value of a and d, and with the help of a and d we can find the complete AP series. So for example, over there when we solve this equations, we will get value of a equal to 3 and d equals to 1. So the AP will be required is 3, difference is 1, so 3 plus 1 4, difference is 1, so 4 plus 1 is 5, 5 plus 1 6. So in this way the terms of the AP will be 3 4 5 6 1. I hope you guys are getting what I'm trying to say. And as I've already told you guys that if anyone has any doubt, please ask that doubt at the end of the session, because right now I'm trying to maintain a flow so that all of you can get what I'm trying to say and what I'm trying to explain, because these are the just examples. The main part is in the exercise. So we will be learning these things so that we can easily implement these things in the important exercise formulas or questions. So check whether 301 is a term of the list of numbers. So we have to find is that whether 301 is a term of the list of numbers. So basically the question is that we have to find whether this AP series consists of 301 number as a part of this series. So we will find it out. First of all, we need to find the difference. So the difference of this AP is equals to 11 minus 5, which is equal to 6. As you can clearly see that 17 minus 11 is also equal to 6. 23 minus 17 is also equal to 6. That means it is an AP. And the first term is 5. So we need to find the value of n. So we will use the nth term formula. An equals to a plus n minus 1 into d. So 301 is equals to 5 plus n minus 1 into 6. 6n minus 1 is equals to 301. N equals to 151 by 3. As n is not coming out to be a complete positive integer, so 301 will not be part of this number series. Now let's start. Let's do the example 7. I hope you guys are with me and understanding whatever I'm trying to say or teach to you guys. I hope I am explaining you guys the concept in a very firm and nice manner. So now the next question is, how many 2 digits numbers are divisible by 3? So basically the question that we have is that how many two-digit numbers are there which are divisible by 3? So first of all, the two-digit numbers are starts from 12 and they end at 99, which are divisible by 3. So the first number which is divisible by 3 is 12. The second number is 15, which is divisible by 3. The third number is 18, which is divisible by 3. And the fourth and the series goes on with 99 being the last two-digit number which is divisible by 3. So let's check whether this series is an AP or not. So clearly the first term is 12, and the difference between 15 and 12 is 3. 18 and 15 is also 3. So we can clearly see that the difference between 15 minus 12 is equals to 18 minus 15, which is a important condition to be make this series an AP. Which suppose that 12 is A, 15 is B, and 18 is C. So the condition which is required is that B minus A should be equals to C minus B. So 12 minus 15 minus 12 should be equals to 18 minus 15, which is equal. So that means this series is an AP. So A equals to 12, D equals to 3, and AN equals to 99. We have to find the value of N. So 99 is equals to 12 plus N minus 1 into 3. 87 is equals to N minus 1 into 3. 87 upon 3 is equals to 29 plus 1 equals to 30. That means the 30th number of this series will be equals to the 99. So basically we have total 32 digit numbers which are divisible by 3. Now let us start with the next example. Find the 11th term from the last term of the AP 1074 ... minus 62. So basically we have to find the 11th term from the last, not from the initial number. We have to find the 11th term from the last. So the A value is 10, D equals to 7 minus 10, which is equals to minus 3, and L equals to minus 62, which is the last term. So L is equals to A plus N minus 1 into D. From here, we can clearly find out which term is the last term. So I know that minus 62 is the last term, but it is at what position? It is what term of the series? We have to find that first. So L will be equals to minus 62 is equals to 10 plus N minus 1 into minus 3. Minus 72 is equals to N minus 1 into minus 3. From negative, the signs will be cancelled, and 3 to the 6 upon 1, 3, 3, 9, 3 over 12. So we will get 24, N equals to 25. So the last term of this series is 25th, and we have to find the 11th term from the last. So suppose we have to find the 11th term from the last. So what can be the its position from the initial? Try to guess it, or try to understand the things. The 11th term from the last term will be the 15th term from the starting. Try to understand what I'm trying to explain to you guys. Listen guys, we have been given to find the 11th term from the last. So if there are 25 numbers and we have to find the 11th term from the last, so that 11th term from the last will have a place value of 15 from the initial point. You can easily do that thing by 11 plus 25, 11 plus 15 is equals to 26, and one position is getting repeat 2 times, so that means 26 minus 1, which will be equals to 25. So that means the 15th position will be the same as the 11th position from the last. So we will find the 15th term. 10 plus 15 minus 1 into minus 3, 10 minus 42 equals to minus 32. So therefore the 11th term of this AP will be equals to minus 32. Now there is also one alternative solution that I can provide to you, and I have also like explained over here. Like you can see that, suppose that we write this AP in the reverse order. We will consider A as the minus 62, and we consider D as 3. Are you guys understanding what I'm trying to say? We are reversing the AP. We are taking A equals to minus 62, which is basically the last term, but we are trying to convert it into the first term, and D equals to 3. So the question now becomes finding the 11th term from these A and D. So A11 will be equals to minus 62 plus 11 minus 1 into 3. Minus 62 plus 30 will be equals to minus 32. So one thing that you have clearly seen over here is that the D value over here is changed is changed from -3 to +3. Why? Because previously we were subtracting a lower value from a higher value, but right now we are subtracting a higher value, lower value, higher value. Sorry, previously we were subtracting a higher value from a lower value, so that is why we are getting negative sign. But right now we are subtracting lower value from a higher value. That is why the D is coming out to be positive. Now let us understand this last concept of our today's lecture, and I hope you guys have learned something new, and you guys have learned the concept of NS term, because it is really very important to understand these things, because these type of things basically create your fundamentals, which will help you in the later exercise that we will solving together. So guys, read the question with me. A sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do this interest from an AP. If so, find the interest at the end of 30 years, making it use of this fact. So basically, हमें assume करना है. Assume that we have 1000 rupees and we have invested it at 8% simple interest per year. So we have to find the interest at the end of each year. Now, there is one catch. They have asked us whether the interest that we are getting from this sum is forming an AP or not. And if it is forming an AP, then we need to use the nth term formula to calculate this interest for 30 years. Now let us see the formula of simple interest. P into R into T by 100, where P equals to principal, R equals to rate, and T equals to time. This is the formula for simple interest. So for the first year, the P will be 1000, rate will be 8, and time will be 1 upon 100. So the value will be 80. For the second year, P will be 1000, rate will remain same, 8, and the time will be changing from 1 to 2 upon 100, which will be equals to 160. Now for the third year, P will be 1000, R will be 8, and time will be 3 upon 100. So we will be getting 240. So clearly we can see the interest that we get on the first, second, and third year are 80, 160, and 240. And we can clearly see the difference between 160 and 80 is equal to the difference between 240 and 160. That means the interest from simple interest basically forms AP. So we can use the formula for AP in this and get the interest of 30 years. So A30 will be equals to A plus 30 minus 1 into T. A will be equals to 80 plus 29 into 80. This will be equals to 2320 plus 80 will be equals to 2400. So the interest at the end of 30 years will be 2400. Now we can clearly see this is our last example for today's class, and from tomorrow onwards we will be doing the exercise 5.2. So I hope you guys have understood the concept of nth term. I can repeat the concept once again. A is the first term, nth term is the term that we need to find, D is the difference, and the formula that we make out of all this is that A plus n minus 1 into D, which will be giving us the nth term of an AP. Now the last question is, in a flower bed there are 23 rose plants in the row, 21 in the second row, 19 in the third row, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? So we have been given that there are some flower beds. The first flower bed has 23 rows, second flower bed has 21 rows, and third flower bed has 19 rows. Rows means gulab. And in the last flower bed, we have 5 rows. So we can clearly see that the difference between 21 minus 23 is equals to -2, which is equals to the difference between 19 minus 21, which is also equals to -2. That means these terms are forming an AP with the first term as 23. So it forms an AP. Let us find the number of rows in the flower bed Bn. So we are supposing that the number of flower beds in these terms will be n. So difference is equals to the difference equals to 21 minus 23, which is equals to -2, and the last term of the AP is 5. So an is equals to A plus n minus 1 into D. We have the first term, which is 23. We have the last term, which is 5. We have the difference, which is -2. So an equals to 5 equals to 23 plus n minus 1 into -2. So -18 is equals to -2 into n minus 1. So from here we will get n equals to 9 and plus 1 will be equals to 10. So that means there are 10 rows in the flower bed. So this is all about the today's class, guys. I hope you guys have understood the concept and all the things which I have told to you. If you have any feedbacks, you can provide me in the comment section. I will try to look at those things, and I will try to make this class for more more exciting and more collaborative. Thank you so much for attending the class. Thank you, guys. Thank you.